All right, here we have a couple spheres. We're just going to find the surface area and volume of these two spheres just to practice our basic expressions. So we'll start with the top sphere. It's got a radius of 8 centimeters, which is perfect because we need to know the radius of the sphere. And let's just start by finding the volume. So volume for a sphere is 4/3 pi r cubed. So we've got the 4/3, that's no problem. We've got the pi, 3.14. The radius is cubed, so that would be the 8. So this would be 4/3 times pi. We've got the radius of 8. We'll cube that. And make sure you actually cube it. It's not 8 times 3 is 24. Okay, so make sure we'll cube that, and we will get our volume out of that. And if we do the calculation, we get about 2140. And I've rounded off a little bit. So 2140 centimeters cubed. All right, so now let's find the surface area. And the surface area for a sphere is 4 pi r squared. So 4 pi r squared. All right, well, same type of thing. We've got the 4, we've got the pi, we've got the radius of 8, so we'll square that. And we can then calculate the surface area. And that would give us about 804 centimeters squared. So there's your basic volume and basic surface area for this first sphere. So let's do the same type of thing for the second sphere. No big deal. The only thing is we have the diameter is 12 inches. So of course we want the radius. So that's just half of that. So the radius would be 6. And other than that, the calculations are almost identical to each other. So again, we get the volume is going to be equal to the 4/3 pi 6 cubed. That would be about 904, and this is inches, so inches cubed. All right, now for surface area, let's see, that's going to be 4 pi 6 squared. So we've got the 4, we've got the 3.14 for the pi, and then we'll times that by 6 squared, which of course is 36. That will give us about 452 inches squared. So there's our basic surface area and volume for those two spheres. Now what we're going to do is we're going to do something else. We're going to bring in another sphere, another fancy sphere over here. There we go. All right, now let's say that sphere, we'll go to give a little value here. Let's say that sphere has a surface area. The surface area for the sphere is going to be, let's say, 300 centimeters squared. And I want to know the volume. Okay, now to do that, I can use the surface area and the surface area formula in order to actually find my radius. So once I know my radius, I can use that to find the volume. So using the function for surface area, which is 300, is going to be equal to 4 pi r squared. Now we want to solve for the radius. So we got a reverse order of operations. So the first thing that we would do is we would take that 300 and we would divide it by 4 to cancel out the 4s. We would divide it by the 3.14 as well. And if we do that, we have, well, approximately left is about, we'll round off, 23.9 is going to be equal to r squared. We then take the square root of this side and the square root of this side. So basically r squared is 23.9. So let's take the square root of each of them. So the square root of 23.9 will give my radius of approximately 4.9 centimeters. If you're not sure if this is right, just take this, put it back into the formula we started with, and see if we get the same value. I mean, this is about 5. So 5 squared would be about 25. 25 times 4 is about 100. That's around 3. So that'd be around 300, which is what we started with. So we're probably right. So now that we have that, we know the radius. We can now take that radius and put it into the volume formula, which is the 4/3 pi r cubed. So now we just take the 4/3. we multiply that by the pi value of 3.14, and then we'll times that by our radius that's been cubed, and we will have our volume for our sphere. Okay, and so if we do that, we will get a volume of approximately 493 centimeters cubed. And that's with rounding off a little bit. Okay, so using the exact same expression that we used for the basic calculations up here, we used in this question. The only difference is we used the surface area function or relation, and we just reverse it, went backwards to actually solve for the radius instead, and then we could apply that radius to calculating the volume using the function for volume to find the volume of our fancy reddish sphere.